jullie er zijn vandaag. Wij hebben wel vaker mensen hier en ja, heel vaak met verschillende onderwerpen. Maar het is eigenlijk de eerste keer dat we wat verder richting Eems gaan kijken met nou, een groepje van onze klanten. Ik zal ook zo laten zien wie er aanwezig is, welke 10 klanten van ons aanwezig zijn. En tegen het eind kunnen we ook wel even een klein voorstelrondje doen, denk ik, dat iedereen dat van elkaar weet. Ik vind het altijd leuk om met kennisoverdracht bezig te zijn, maar ik vind het ook leuk als jullie met elkaar een beetje in gesprek raken en wat ervaringen delen met elkaar. Dus ik hoop dat we dat tegen het eind van de dag met z'n allen met een borreltje erbij nog even kunnen doen. Ik ga eventjes 2 minuten iets over Motion 10 vertellen. Sommigen van jullie hebben al wat langer niet meer met ons gewerkt, sommigen werken op dit moment met ons. Dus het is denk ik goed om eventjes weer op te frissen waar Motion 10 staat op dit moment. Nou, wij zijn van oorsprong gestart als BizTalk specialist en dat is 10 jaar geleden geweest. We hebben 2 weken geleden hebben we ons 10-jarig bestaan gevierd met onze klanten, op de 10e van de 10e. Nou, in die 10 jaar tijd is er heel veel gebeurd. We zijn heel ver, ja, we zijn eigenlijk allerlei andere Microsoft technologieën gaan oppakken naast BizTalk Server. Zoals dat hier uitgetekend staat, we zijn naast de integratie ook veel bezig met Azure Development. Business Productivity en Change processen, eigenlijk alles wat met Office 365 te maken heeft. En Data en Analytics, waar heel veel van de BI-processen, maar ook AI in zit. En dat zijn eigenlijk groepen van consultants die ongeveer even groot zijn, zo'n stuk of 30 consultants. Er zijn een totaalbedrijf van zo'n 130 medewerkers ondertussen, dus het gaat eigenlijk hartstikke goed. En ik vind het leuk dat we vandaag nu ook integratie en AI bij elkaar zien komen. Dat is toch wel een van de doelstellingen vandaag om daar wat verder op in te gaan. Nou, als je kijkt naar integratie, het voormalige speelveld van BizTalk Server, dan is dat best wel uitgebreid. We krijgen tegenwoordig heel veel vraagstukken, niet alleen over BizTalk. Wat is de toekomst van BizTalk nou eigenlijk? Komt er nog wel een nieuwe versie? Tot wanneer is er nog support op? Maar ook wel, hoe moeten we nou naar de cloud? We hebben steeds meer applicaties en services vanuit de cloud en hoe gaan we dat integreren? Moet je dan ook een stukje integratie vanuit de cloud doen? Moet je dat hybride doen? Moeten we onze hele BizTalk-omgeving naar de cloud brengen? Er zijn best wel veel vraagstukken omheen. Hoe belangrijk worden API's? Nou, ik had net met TU Eindhoven al even over, dat je steeds meer integraties in de organisatie ziet, maar dat je de governance daarop toch wel op API-niveau wilt hebben. Dus API-management zien we heel erg belangrijk worden. Veel vragen ook daarover. Wat we ook heel erg zien opkomen is steeds sneller applicaties ontwikkelen. Dat heeft te maken met digitale transformatie, dat je ook snel nieuwe businessinitiatieven in de markt kan zetten. Nou, we zien bij veel van onze klanten Mendix komen of OutSystems. Eigenlijk platformen waarmee je snel applicaties ontwikkelt. Maar die moeten ook weer geïntegreerd worden in je landschap. Hoe ga je op dat moment met de integratie om? En een laatste vraagstuk, wat eigenlijk al jaren leeft, is hoe monitoren wij onze integratieomgeving? Maar dan heb ik het niet alleen over BizTalk Server, maar misschien ook wel wat breder. Met de Azure-initiatieven die er nu zijn rond de integratie. Nou, monitoring, we hebben op BizTalk altijd met BizTalk 360 gewerkt. Veel van onze klanten werken er ook mee. Totdat Eva in dienst kwam, die heel veel over Eames begon te praten. En we hadden zoiets van, nou, daar gaan we toch eens een keer serieus naar kijken. Dat hebben we ook gedaan en Eva is een echte voortrekker erin geweest. En heeft er ook voor gezorgd dat de Goudse de eerste klant is. De Goudse verzekeringen die met Eames is gaan werken. Daar ook enthousiast over is. Als je kijkt op de Eames website, dan staat er een referentiecase en ook uitgelegd waarom ze zo enthousiast zijn over het werken met Eames. Ook hoe het proces ging naar het voor het eerst aanzetten van de omgeving. Nou, het is voor ons heel erg leuk om op die manier met de Goudse weer een nieuwe stap te maken en ook AI toe te passen op de integratiepatronen daar. En ook wel een reden geweest om de volgende stap te maken, om met jullie eens te kijken naar, zou Eames zinnig zijn voor jullie? Wat betekent het als je Eames aanzet op jullie BizTalk-omgeving? Misschien dat sommigen van jullie dat al een paar weken hebben draaien om te zien straks wat er in de lab gebeurt. Nou, en anders ga je vast wel een goed beeld krijgen bij wat Eames nou precies doet op monitoringgebied. Het gaat een interactieve workshop worden met wat sessies tussendoor. Gijs zal aftrappen straks met een verhaal over onze visie op digitale transformatie en de cloud-transitie ook. Dus het steeds verder brengen van je applicaties naar de cloud toe. Nou, Eva die zal straks iets meer vertellen over de verschillende labs die er zijn en presentaties daaromheen. Jullie hebben de agenda gezien. Het zal nou, lekker ook een beetje zelf bezig zijn. Mocht je nou niet van de afgelopen 3 weken informatie verzameld hebben, dan is er ook wel een oplossing voor. Dat komt wel goed. En wat ik al zei, laten we aan het eind van de dag nog eens evalueren. Hoe is het verlopen? Wat zou Eames kunnen betekenen? Maar ook wel, ik ben in het algemeen wel benieuwd naar hoe jullie tegen integratie aankijken. Nou, ik zei al, ik heb even kort samengevat welke klanten van ons er vandaag zijn. Dus ik zou het leuk vinden als jullie eventjes in 30 seconden vertellen van welke organisatie je bent en wat je rol is bij die organisatie. Ik maak straks het net.
So my name is Gijs. So this is a great quote by Darwin, of course. It's not the strongest or the most intelligent that survives, but the ones that are most adaptive or adapt to their environment are the ones that will survive. And that's basically what we're in today in that situation when it comes to digital transformation, to cloud computing. A lot is happening around us, and we have to constantly adapt to the things around us to make sure that we survive. So we come from that left side, where we have a stable environment with a number of fixed back-end IT systems and a number of customers, and that's basically the traditional business that we had. And now on the right side we see more and more that we have to deal with ecosystems, that we have to communicate with all kinds of partners around us, that we have to do with things like Internet of Things, multiple IT systems, multiple SaaS services that we have to deal with, and of course customers that are more and more demanding. So we have to move from a traditional business to a digital business. So on the left side you see the traditional business, where we have multiple applications and an ESB that makes sure that these applications can actually exchange information between each other. And on the right side we see a very diverse application landscape with on-premises applications, Internet of Things, with SaaS services. So we need a lot of capabilities to be able to integrate all these different applications and services. So again, move from traditional business to digital business. So in the middle, what we do is we build a smart data and integration hub to make sure that we can operate in the digital ecosystems that we are all part of, and that we can exchange information and also exchange that information towards, for example, portals or apps or other means of accessing that information. So Wilfred and I went to the Gartner Summit in June in London, and that summit was in the same week as the Microsoft integration event in London. So that was nice. So at that integration event, Microsoft disclosed all the new inventions and developments in the integration space. And at the Gartner conference, we got to know Gartner's vision on integration, architecture, and development. And basically, one of the things that they said was that integration is at the core of digital business technology platform. So integration is a very important piece of your application landscape. So the more you innovate, the more you have to integrate. And these are all the reasons that you see on the left that mean that you have to integrate. So for example, incompatible technologies. We all recognize those. Or multiple use patterns and interaction styles. So it's completely different to have integration between an app that needs immediate response, or do batch processing of your invoices every night. So all these different integration and interaction styles should be supported in your integration platform. And of course you have the different base layers. So I don't know if you ever heard of the Gartner application base layer model, where you have the systems of record and you have the systems of differentiation and innovation on top of that. So you have to be able to enable that pace of change, and you can do that with a digital platform that supports integration and smart data. We all want to modernize our applications, and these are the three things that you that basically um, that you do to modernize your applications. First of all, you gather all the data and make it smart. So that's an important piece of your modern application environment. And the second is you have to expose that data in a simple but very secure way. And the third is that you have to add innovative interaction styles. So, for example, add chatbots or artificial intelligence or things like that. So basically what you see in the middle is that the integration is a very important piece of application modernization as well. And this is where we talk about APIs, for example. When we look at the evolution of software architecture, so we came from the mainframe and today we are in the API era. But in every organization where we come, we see all these different software architectures. And that also means that you need integration in your own landscape to be able to integrate all these different software architectures. And on the left side you see all kinds of trends. And for example, we see that applications get more and more distributed. So instead of having one silo application that can do everything, we have a very distributed application landscape with all kinds of SaaS services, for example. We see that applications that we build have to be mobile first because lots of users are using a smartphone or a tablet to access the information and the processes. We see that modern applications are built on top of microservices and APIs. So we can actually do continuous integration and continuous deployment of those services. Instead of doing a release every year or so, we can basically release every day. And because we use more and more SaaS services, it is very important to have that out-of-the-box SaaS connectivity, basically. Then what we see is that we see a lot of PaaS services, for example in Microsoft Azure, that are used for integration and application development. And of course, Azure Integration Services is the integration platform as a service provided by Microsoft. And it's a true serverless platform, so you don't have to bother about technical maintenance of the servers in your integration landscape. It is serverless, so you only are responsible for the functioning of your interfaces that you're basically building on top of it. Then two more things that are important. We see more and more that the self-service integrator is a role within companies. So the traditional integration competence center where every integration is done is still there to do the enterprise-wide integrations, but you also see within the lines of business or within departments that there are self-service integrators that are also capable of doing local integrations between their applications. But we have to make sure that they operate under governance, and that's where the Integration Competence Center comes in. They have to make sure that the right patterns are used and the guidelines and development guidelines and stuff like that. But it is a real thing today in modern businesses that the self-service integrator is also a role within your organization. And last but not least, DevOps is important. With the cloud, innovation is constant, and with a traditional IT organization, it's impossible to make the right use of cloud computing. So instead of having an IT department with development and another department that is responsible for keeping the systems up and running, so operations, with a wall between it, you now have DevOps teams that are responsible for certain functional domains, and they do the development of integrations, but also the front end and the back end. But also they are responsible for keeping the systems up and running, so also for operations. And then with that you are capable of moving more at a more high speed, building integrations, building tailor-made solutions and so on. When we look at that base layer model by Gartner, so you have the systems of record and you have the systems of differentiation and innovation, we can see that here you have the enterprise integrator, which is responsible for the enterprise-wide integrations, and they are also responsible for integration patterns, architecture, making sure the platform is up and running and things like that. And then on top of that, you have the agile integrator. Within the line of business, they do integrations in their own department or line of business. And on top of that, you have the self-service integrator. So those are the folks that automate their own tasks. And these folks are responsible for the platform governance and keeping it up and running. And these folks have to adhere to the guidelines that are provided by them. And when we look at tooling, these typically use Microsoft BizTalk Server plus more and more the Azure integration services. And these use the Azure integration services and they use Microsoft Flow. So integration governance is, of course, in such an environment very important. You have to make sure that they all use the right architecture and patterns. So design time, architecture development and enforcement, development guidelines, security policies, API catalog management, those are all things that are done by basically the Integration Competence Center. And here you can see that, for example, end-to-end tracking policy is important at design time. And at runtime, you have to make sure that the integration platform is operated and keeps on running. But here you can see that things like health monitoring, operational analytics, and API monitoring are very important roles and things that have to be done within such an environment. So your application landscape is becoming more complex. You can see that you use more integration tools. It's not only BizTalk Server, but it's also Azure Integration Services with API management, with logic apps, with event grid and things like that. So the landscape is becoming more and more complex. And you need to have the right tools to be able to monitor and manage it. So this is a typical architecture that we see. So you have your on-prem applications and databases. You have all kinds of SaaS and PaaS apps. And on top of that, you create your integration layer with, for example, your on-prem BizTalk server, with Azure integration services, with all kinds of data services. And on top of that, API management to expose those APIs to, for example, a portal or an app, or, for example, a low-code platform like OutSystems or Mendix. And these are the technologies you use there. So here you see Azure Integration Services, BizTalk, all kinds of storage in Azure, Azure API management, and on top of that, Flow, Power Apps, Power BI, all those self-service tools that you use and that need those APIs to access the data and the processes. And of course, you have to be able to monitor that environment and manage it. And the things around security also have to be taken care of course. So you can imagine that in a more and more complex integration landscape, the management and monitoring of such an environment becomes more and more important. It's not only a BizTalk server that you have to monitor, it's more complex than that. So tools like BizTalk 360, Atomic Scope and AIMS are becoming more and more important in such an environment. So that's basically what I wanted to tell. It's becoming more complex, monitoring is important, and that's my little bridge to the next session about AIMS. Who's next? Ricardo. So you use your own laptop or?
I have some demos to do, so I'm not sure if I should use that one, but I can try. There is a browser, I assume, so I can try and.
I guess.
And
yeah. I'm not a technical guy, so.
Ricardo, you do have a service, right?
Yeah.
At the docking station, you need one.
Yeah, no, I'm just wondering if I should use this one or my own. I don't think I would need the, but
Need a browser?
as long as there is a like Chrome or something, yeah, Chrome is there. That's fine. I can do it from here then.
Hi, by the way.
Sorry, I arrived late. That was my mistake. So let me go and do that. Thank you. All right. First of all, hi everyone. I'm Ricardo Torre, and I'm head of customer success and technical evangelist at AIMS. So my goal today is that you can learn as much as about the AIMS as possible. So let's try and make this as interactive as possible. So feel free to ask questions. Pull me next to you so that I can help you with the labs or anything else. We will be starting with a lab, which you should have received, or there are also some hard copies here somewhere. So after that we will go through some slides. I'm just wondering if I probably would prefer to go through the introduction and then go to a lab. It's just I'm not sure how much people know about the whole platform, so I'd rather just give that intro and then move to the first lab. So okay, I think some formatting is not really right, but should work. Okay, so I like to start with the monitoring challenges, because these are the things that are the reason why the product exists, and these are kind of the drivers to have created it. And so we come from the integration world. This is how AIMS was created in the first place, as a BizTalk monitoring tool, which then generalized into a more a platform that's generic for any application. But a lot of the people here, I suppose, work with BizTalk or Logic apps. So who does not? So just so that I know. Okay, everyone does. Yeah, okay. Maybe one or two that don't. So which is a good place for me to describe these, but of course I'll try to be as generic as possible when describing the platform. But there are a number of challenges that we face when running software, and it's important that we know which of those things are important to be aware of, and this is where we start. So if we start within the BizTalk world, it's important to know whenever there are configuration changes. And this means like people deploying things, changing settings, changes the status of services, etc. So things that affect the environment in some way that you want to be aware of. Then, of course, there are errors that happen. This is suspended messages. This could be errors in the event viewer. It can be a number of things. It's important to know when they happen, because generally you have to take some action to be able to go to make sure the business is actually executing and that business messages are being integrated. Then we have, of course, performance, and we want to make sure that the environment is performing well, and to do that we need to be aware of a number of performance indicators. One of the very well-known ones is, of course, throttling. You want to know when BizTalk is throttling, which parts of BizTalk are throttling, what are the reasons, and therefore then be able to go past or avoid throttling altogether. But being in management, you want to know how much of the capacity of the system is being used, and so that you can also project how much is left, and if you need to scale your environment or do some kind of optimization to be able to process what your business is demanding. And the same thing applies at the server layer with the server performance, which normally includes those typical things like CPU, memory, network, and disks. And it's important to identify physical bottlenecks, getting to the limits of what's happening there. And then, of course, there is SLA management. Oftentimes platforms offer some kind of performance requirements, and by managing these SLAs, you will be sure that you can you are delivering the service that you agreed to deliver on. And so although these are BizTalk specific, they are also very common across multiple applications on what you want to monitor. And a good example is logic apps, and you will also want to know about configuration changes. So whenever there is a new deployment or someone starts or stops the logic app or something of that nature, you want to be informed of that. Then any errors or failures that are errors executing or triggering your logic apps are important to be informed about. And of course performance, and this takes multiple facets, but one of them is of course the performance of the actions, each of the individual actions within a logic app, but also if you are using a hosting model that uses app service plans, you want to make sure the app service plan is big enough to handle the logic apps performance you need. And so this brings us to the platform. Some colors here. I think there it looks a bit better. Okay. So this brings us to the AIMS platform, and so we built this platform the platform is responsible for ingesting data, and these are metrics, metadata, and events. And this can come from any application, and as we ingest that information, we are also processing it through multiple machine learning algorithms. And the goal there is so that we identify what's the normal behavior of a system. And you can think of a baseline of all the metrics that are being ingested. And then we, after we have some historical data, so that we can start also then predicting what's expected for each metric at each point in time. And also whenever the metric is outside of that range, you will be essentially identifying an anomaly. And so that we have machine learning algorithms to identify those anomalies and generate anomaly reports, which are essentially the list of all the metrics that are not working as expected or intended. And and that will be a starting point for you to then go over the data and get a better, more deep understanding of how it is working, and be able to take actions and essentially remove those problems. Or also, sometimes you might get an anomaly that's due to changes that are natural and expected from the environment, but that you still want to be informed about those changes to see if they are within the ranges of expected, and then you can inform the system and help the machine learning algorithms to know what's normal, what's not normal, and take it from there. One of the main goals of this platform is to move you from being reactive, so expecting a problem to happen, or waiting actually for it to happen and then taking an action, to be before that. There are a number of indicators that tell you this is going to go bad at some point. It can be the disk that is getting full, it can be the CPU that is getting overutilized, etc. All of those small indicators will get you there. And we are normally, when we are ingesting metrics and metadata for a particular system, we are ingesting thousands of metrics, which can be very granular and nuanced, so that they help you understand how the system is behaving. Then another important goal of the platform is that that you make very little effort into setting it up. So the expected effort for setting up AIMS is that you will install the agents, and then once the agents are installed, which require of course some kind of permissions against the system, they will be able to figure out how it's configured and start pushing the relevant metrics to our platform. But after that, you're not expected to need to do anything else to be able to get some insights and, of course, also alerts of things of importance. So there is no need for setting up thresholds and know how to expect that environment to work. And again, the goal is to move you from that reactive state into being proactive. So knowing things early on so that you can take action and essentially focus on what's more important. And this is another important aspect that I often refer when talking about the platform. We are capturing thousands of metrics, not because we like to say it's thousands of metrics, it's because each of those metrics means something slightly different. And by knowing about all of them, we can know more and be more in depth into that environment. And I can relate that with my experience. When I worked at Microsoft, I used to see a lot of different BizTalk environments, and I would have to analyze a lot of them, and I would have to go and capture some metrics. And I usually would capture 10 to 20 different metrics and analyze them, and based on that, iterate into recommendations or more action to get more data about the system. But I would be biased towards the metrics that I usually looked at, and I would often miss nuances that are particular to a system, such as, let's say, there was a new deployment that increased the number of messages in the environment, and therefore it reached capacity and start throttling. That's a simple scenario that I would struggle a lot in with just looking at 10 or 20 different metrics to arrive to. And by having thousands of metrics, capturing all the historical data, being able to go back in time, know when the deployment happened, and how metrics changed after that, is something super powerful to be able to know what's happening there. Okay, so I tend to speak through these slides without moving to them, so I'll just add a few points as we go. So one of the goals is, as I said, full automation and no manual configuration required, so no thresholds to be defined. We are also doing transaction tracing, and this is to identify how messages flow through a BizTalk environment. This is done by looking at the runtime and seeing how messages flow between services, and creating this dynamic map of those, essentially as we call message flows, and then capturing metrics on top of that, so that you are informed of from a business process standpoint as much as possible. Of course, very scalable, and this is a super important aspect of all our agents, but maybe there is even a bigger impact in the BizTalk one, which is near zero performance impact, because we're not depending on tracking, and so therefore, even when tracking is disabled, we still see all the processes going through and taking metrics about all of those processes. So maybe I'll just skip to this one. All right, so just quick reference of our customer base. So we have customers around the globe, large customers across many industries. It's mostly Microsoft-centered customers, because we born out of BizTalk world, but we are expanding into a whole lot more, and we will look into some of that really soon. So let me just
in the introduction round, there was a question on that, because one of the people has a hybrid infrastructure with BizTalk, but also X-Way and Clio.
With what, sorry?
Deal with that, like X-Way for integrations. They use that next to BizTalk server. Can you do something with X-Way as well?
Yeah, I don't know that name, so myself, but the platform is generic, so that's an important aspect. We just need those metadata metrics and events from that system. So as long as we can capture that, we can build an agent out of the SDK, which pushes data into our platform and benefits from all the things I just described. So as long as there is an agent, and the agent can be built with the SDK, that would not be a problem. And so that can be either a custom project built if it's very specific to a customer, or it can be it can be done by us as a project, or by the customer as a project, or if there is enough demand in the industry, we can build it ourselves and make it available. So all of those options are available. And we're going to talk through the SDK. Actually, I included slides about the SDK because I think it's an important. Yeah. So the idea is that to show it's not that hard. So it's as long as so someone has the knowledge about the application, they will know where those metrics are available, and so it will be easy to just capture them and push them. So this is where we are today in terms of agent support. So we are covering the on-premise scenarios, so including Windows Server, BizTalk Server, and SQL Server. We're also including here Service Bus and Logic apps, and these are services, PaaS services within Azure that are oriented towards integrations. And we also have a number of open source agents, and the goal of these open source agents is exactly that, to showcase how can you build an agent and use the platform to benefit from monitoring those services. Of course, we use it with these two purposes. We want to cover IIS, but we also want to show you how can you do it. and we also do file count monitoring and HTTP endpoint monitoring, but you can essentially expand it to anything else. It's a .NET-based SDK, which under the covers, what it does is calls REST APIs against our backend to push those three data types that I just mentioned. So here we're gonna just briefly look at some of these pictures. These are pictures from the product, so you get an idea on how it will look. The first one is messaging patterns, and this is what I was saying, that we are mapping how the system looks like. We're looking at the messages going between services, and we draw these diagrams where you can see which artifacts are involved, and then we are also overlaying the health of those artifacts by color coding, and you can click and see details, of course, such as errors that are associated or anomalies that are associated with each of those artifacts. These are done automatically. You can also customize them if you want, like you can force them to be slightly different if you prefer them in a different way, but they are built automatically. Then the picture number 2 is the visual outcome of the machine learning algorithms. You can see here what you see is a metric varying over time. The red line is the metric of message count in a particular artifact, for example. And after a while you have this blue area, which is essentially the dynamic thresholds that we are associating with that metric. And those are calculated by the machine learning algorithms. And then whenever the red line comes outside of that blue area, it means there is an anomaly in that particular metric. And so based on the number of anomalies that are happening, how they correlate with each other, we will generate an anomaly report, which is then emailed to you so that you can essentially start the troubleshooting process. And then last here is about the analytics capabilities, which is something I actually missed in the introduction of AIMS, which is we are capturing all of this data, but we are of course storing it, and then we allow you to build visualizations of such data. So the data is used for both the machine learning, of course, and figuring out what's going wrong or potentially wrong with the environment, but also to then create something that elevates that data into something meaningful that can be consumed by multiple people across the organization. So it doesn't need to be technical. It can be technical, such as throttling information or errors, etc. But it can also be associated with the business processes, for example, and you can share that with whoever is interested in such business processes, so that they can be aware: are they healthy? Are they not healthy? What are the volumes, etc. So you can essentially build then visualizations that are meaningful to you and share them across the company, and you can even schedule to receive it via email so that it's easy and you don't have to even think about it. All right, so I was planning a demo here of the product, but and probably I will. So that's I was thinking out loud now. So let me go here. I'll just have to sign in. So so you will need this URL. You can go to aims.ai at some point, and you will be landing on our page, and you can click in login to go into the product. And so I expect that you have registered before at least and created an environment and installed the BizTalk agent. If none of that happened, that we're still on time to do it, and I have an environment that I will share with you to be able to perform all the labs. So you will have to sign up if you haven't signed up, and then once you're signed up, you will have to tell me your email so that I can go and assign permissions to the environment we'll be using. And so for the sake of the demo, I have to log in. Sorry.
Voor iedereen die op het gastnetwerk wil, het wachtwoord is 42.
Would you like to use your own laptop?
Well, that would make my life easier.
Yeah. We
Because
can. What is it? What
Tip.
surface?
Yeah.
All right.
It's just that I don't have to seek my passwords and all that.
Yeah, exactly. Do you have the extension?
For what? For I have one for VGA, but I don't have for.
Okay, then I will get one for you.
Perfect. So I don't know passwords anymore. So that's the. I use LastPass for all of them. So it's always a tricky. So what happens when you lose the last? Is that a way to recover it? Yeah, I think so too. Oh, you have one.
Yeah, of course.
Yeah, I have one, the old one, not the good one. So, I can do this.
I'll take the other.
So where's the HDMI cable? What do you need? The HDMI cable. This one? No, I believe it's over here. But is it? Does it allow wireless or just if I'm in?
There's one. I don't know if it can reach it. Maybe you have to move it a bit back. It's possible.
Okay, perfect. Thank you. Yeah, I also need internet. So if I use this gas network, will I?
42, it's possible.
42.
42.
Well, it's the answer for everything, right?
Yeah, exactly.
You're okay with the internet connection?
Yeah, I think so.
Yeah?
It's all starting to show up, so
Okay, good, good.
just confirmed. All right, so
was racing.
we made you go through so much trouble that we figured it out.
Yeah.
Sorry.
All right. Well, it worked. That's
Thank you.
important.
Yeah. All right, so I want to capture everyone's attention again, if I can. We can sort out the registrations a bit after. I just want to go through the demo. I'm gonna spend like 15 minutes or so, and then we can sort out the emails access and all that. I'm gonna try the silence to see if it works. I'm just trying to capture everyone's attention for a little while. Yeah, sorry. I made the disruption, so sorry for that. But I just want to run the demo quickly, and then we can go into the lab, which will be where you'll need accounts. So this is where you land when you're in an AIMS environment. This is a dashboard that has been customized for this particular environment, and there has been a lot of mess with it, which is perfect for us today because we will be using it for labs, and there is plenty of anomalies to analyze and events, etc. But so this is a visualization, essentially looking at some of the data of the environment and making it available to you. In this case, we can see here the first dashboard, the first chart here as the volume of messages going through this BizTalk system, split by a messaging pattern or a business process, if you will. And we also have an overlay of the delays here, so that you can see delays happening and versus the messages, etc. And here we can play with the visualizations to remove or add something to it to kind of understand how it's going on, and also to understand the volumes of messages throughout the day, and eventually compare it to what you know and think of. Then we also have here a few components that are not charts, even though charts will be the biggest and most common ones. You can see here errors and anomalies, and this is comparing the current week versus the week before, and we can actually see that there was some problems with this environment because straight away we can see there were 36 errors the week before, and is now 43,000 this week. So there has been a few some disruptions, and we can also see anomalies. They all went up from all the types, and we can see why. So significant disruption to this environment. Then we also have error changes, and so all these errors that are here, these are grouped from the environment, and you can see they were all 0 last week, and they are quite a few this week. And then we also see activities and changes, and these are any deployments that are happening across the environment that changes it in some significant way. We're keeping track of all those changes. Essentially, it's changes in the nodes that are being captured, and we can see some of them here. You can play with a duration in days to be able to see something that happened a bit before. And we also have here the number of messages going per business process in this particular environment. This is oriented for like a city that has a bunch of systems that are integrating messages. Of course, this is fake. It's just a test environment that we use for demo purposes. But this gives you an idea of the visualizations. But I think for demo purposes, the next place that makes sense for me to go is into topology. And this is where we see what's currently connected to this environment in terms of agents. On the left-hand side, you can see there the agent types. We have Windows Server, BizTalk Server, SQL Server, Logic Apps, Service Bus, and IIS. And then on the main dashboard, on the overview, you can see one box here for each of the system instances that are currently connected here. And then we also see a few of them are grouped together, and this is to make sure that anomaly detection happens across those multiple agents. And this is something super common for a BizTalk environment where you have SQL Server, BizTalk Server, the Windows Server where it's running, maybe IIS as well, and it's all grouped together so that an anomaly that happens in, say, let's say SQL Server that reflects on BizTalk metrics, we have all of that in the same anomaly, and you can correlate that and essentially find the root cause of what's causing the problem altogether. Alright, so that's topology, and I will go a little bit deeper into topology. So I'm going to go and navigate to BizTalk Server, and here we can expand this to see what are the different metadata types that we are capturing for this particular environment. And it's a bit small there, but we have all those familiar sections that you imagine a BizTalk system. We have the BizTalk applications, we have like BizTalk groups, BizTalk servers, assemblies, etc. And from here we can actually expand and navigate to those metadata entities to see a little bit more from them. So if I click in this application called Public Transport Location, we can see here some data that includes metrics, metadata, properties, and connections, and also errors and anomalies associated with it. And we don't see any metrics here on top because at the application level there are no metrics, but once we navigate to the artifacts within the application, we will see a lot of those metrics. We see a few properties related to the application, but more important, what's within it. In this case, we have a receive port, an orchestration, couple send ports, and of course an assembly. And from here, we can actually navigate to that particular port, and we can see the next page where we can actually see here it's a node details that are slightly different from the other one, but the principle applies all the same, which is we are showing the metadata node with some of its properties, relationships with other sections of the agent, such as we need in which application it's stored, what are receive locations that are existing within this receive location, as well as errors and anomalies that are associated with this particular port that has been selected. And then on the right hand side, we can see this node statistics where we can see message volume, message delay, and message count. And here we are also showing these blue areas, which are the corridors or thresholds applied to each of the metrics, so that we have an idea of what's currently happening, if it's normal, if it's not normal, etc. And for instance, this equates to an anomaly because this red line is clearly outside of the blue area for this particular receive location or receive port. Sorry, and so that correlates with the anomalies that are identified there. There are 5 anomalies in which this port is actually involved, and so we'll look more into that. But if I now scroll a little bit back, what we can also see is that we loaded something beneath it, and this is the messaging pattern. This is where what is the process within which this particular port belongs to, and how does it look like. And we can see here we looked at this port that I have mouse over, and then it subsequently calls an orchestration which calls a couple of send ports, and we can see here there are a number of errors and anomalies associated with it, and we can see where those are in a bit more detail. And this shows, so this is to improve and simplify the way to analyze this business process. That's why we capture it in this way. And of course you can then navigate and grow more granular to see what's going on and why is it different. And what we can actually see as big difference is the delays that are a whole lot bigger than before. So a good segue from here is to take a look at those alerts and errors and anomalies. But before that, I just want to show you the depth of other agents, and even within the BizTalk agent a little bit more. So these are very focused against the applications and artifacts, but we also can go and see things like host instances and see properties of a particular host instance. And those will include a number of metrics, as we can see here. Those are the typical expected metrics for a host instance, such as how much memory is it taking, if throttling is affecting it, and a few related metrics that inform about the health of this particular host instance. You can also see a few properties and of course relationships with the hosts and servers in this host instance. That also applies for all the other things, such as orchestrations, ports, adapters, locations, pipelines, etc. Each of those, they have a page which you can expand, navigate to, and see all the details. In this case, we can see it's actually not being used, this particular one, because it landed on the ungrouped nodes. And then quick note on, let's take a look at another one. So we started from, of course, the top, the BizTalk. This is a SQL Server, and so what we're going to look here is that there are a number of metadata types associated with the SQL agent as well. And we can start with something that we are all familiar with, such as the databases. And we, as we did with BizTalk, we can go and navigate to one of these and see the detailed page of that particular database. And so what we will have here is, again, metrics, some properties about this particular node, errors and alerts, as well as relationships with other parts of the database server. So detailed information about each of the databases includes, for example, CPU, reads and writes, and a few total size, growth, related events, and I can navigate into the event section to see what is this particular event that's affecting the server. And not only that, this is one particular event. We can also see events that are similar to that happened over time. And this, of course, helps understanding those scenarios where something is always happening and it's not important, versus something that just started happening and you need more to pay attention to it to know if it's something relevant or not. And of course, we can also query more events that are happening on this server by going here into all events. And this essentially is querying this next section that I'm going to be talking through, which is the event section, where we can see all the events that are being captured across this environment. And those are coming from multiple places. They are coming from Windows, like the event viewer. They are coming from SQL, executing jobs. Anything that is considered an event is captured and pushed into here. One of those event types is the anomalies. And so when our platform identifies an anomaly, it generates the anomaly report as an event of a special type, which we'll then be able to see in a bit more detail. And here, of course, we can see all the events that are affecting this particular node. And we can also then filter and essentially look for what's going on across these, in this case, this particular server, but we can also look generically by not filtering and look at all events that are going through this environment. We can also do search, free text search across all of these events, and one of those that I want to show is, of course, the anomalies. So I'm going to quickly go through one of those. And so you can see here we have a number of anomalies, and I'm going to choose one of these first ones because is super simple to analyze, because it just involves one logic app. So it's a super simple one, just has one metric deviating, so it's as simple as it gets. And here we have, so it's an anomaly. It's considered active right now, so it started about an hour ago. And it's related to the action latency, so it's executing an action within a logic app. And this is the logic app node that we might want to look. So I'm going to click in it to see how does the metric look like. But what we have here as information right out of the gate to analyze is this is the range of expected latency, something between 0 and 0.2 milliseconds. And we have 1.8 milliseconds in terms of latency. So there is a significant deviation from normal latency, even though it's quite small. So it's probably not something super important, but still is something that is actually happening and not normal based on history of this metric. So if I go back to that particular logic app, we can take a look at that. And now I want to see the action delays. Action latency, I believe. Yep. And so here we go. So we have, the blue line is almost not visible there, but it's there. You can see there is the blue line there, which is almost 0, and then we have the actual value, which at some point was 166 milliseconds. So it's like more than 100 times or something like that, bigger than what it used to be. And we can of course change these into slightly different time windows to have a deeper understanding of how it normally behaves. And we can actually see here a 31-day view where we see a clear jump there. That was something going on right there. And this is actually related to one of the downtimes of these systems, so it actually matches the expected. So once we look at this, so I've got this report. This tells me about the metric that's deviating, and if I would go to my logic app, I would see the logic app has had trouble connecting to my on-premise BizTalk, because this is an hybrid scenario, and I would be able to essentially see that there is a downtime in this particular BizTalk server. So that's what an anomaly is giving us. But this one just has one metric, so it doesn't gives us enough to work with. So I'm just going to jump to a different one that has. I don't want one that is too big, but I want something average size. Maybe these. And here what we see a number of metrics as deviated from normal. So again, we have this green bar which tells us the expected range on average for this particular anomaly, and we also have the actual value, which is a whole lot bigger. And we have a number of these that are happening. And so this gives us an idea, and these deviations are not super high because we can see even some of these averages land on the green area, which essentially gives us an idea that at some point during this period there was a significant deviation, but it was not over the duration, the full duration. And so one thing we can do to better understand an anomaly is to jump into the timeline bars, because this gives us an idea of how was the progression of this anomaly happening? Because an anomaly happens at some point or starts at some point, but then it changes over time as metrics change. Some metrics will start deviating and become anomalous. Some others will stop deviating and essentially go back to normal. And this gives us an idea which ones entered an anomaly state and out of anomaly state throughout the anomaly. And this helps a lot with focusing on what's important, what started and triggered the problem, so that you can figure out the root cause and essentially classify this anomaly. And we can see there was some problem here related to available size, and then there was a number of other metrics that after a long while started kicking in. And that's the vast majority of this anomaly, except for this disk space problem that started at the same time and remained throughout a bunch of time. So this is already giving us a hint of what was the problem on this, but let's not dig too much there. All right, so I think this is good introduction for anomalies, but it's a lot of information, so it's better to play with it. So I'm going to go and skip to the last part of the demo, which is to show the analytics section, which is essentially the ability to build these reports that show us the data that is being captured. And what we see here is actually the default BizTalk dashboard that we ship with our agent. And you have an immediate overview of suspended messages that are going on in the system, throttling, if throttling is affecting it, message delays, essentially how much time messages are taking on average, message count, so how many messages are being processed through the system, and all of these 4 charts are comparing the current week with the previous week, and that's why we have these 2 different metrics here on each of the charts. And then we also have an idea of how many messages are going through the platform, but broken down by the business process, and we also have some of the other components we've seen in the other one, such as the activities and changes, which shows what has been changing over time in this environment, and also unhealthy components, so meaning components that are associated with anomalies or have errors associated with it. And so that's quite a high-level overview of a BizTalk environment. We also ship for different agents different reports. In this case, this is the SQL one, where we can see some overall metrics of this SQL server and how it's been behaving over time. And we also group some of these components by CPU, disk reads and writes, so that you can see what is responsible within this environment for consuming more CPU or more reads, writes, execution count, or any metric. Essentially, you can see which components are the ones that are contributing the most for that particular metric. And then another thing to just quickly showcase is that these can be built by you, and you can start from scratch like this, and you can add a block to it, and then we can struct from there. The most common block that you will be adding is a chart block, where you will be pulling metrics essentially on a chart, and you can choose different timelines and resolutions here, such as what's the last 7 days, in this case by default, but you can choose calendar, week or day or month. You can also choose specific date ranges if you want to analyze something very specific. Then you can select metrics by looking at the systems as a whole, or even all systems, but let's start with just a particular system. Let's choose something familiar, such as a BizTalk server, a BizTalk group, and then here we can see which metrics are available. And we can then say, for example, I want to know about the message count, so number of messages going through this system. And then we can also play with visualizations, so that we can break down these in more consumable chunks, let's say. And also, for example, I can put multiple metrics in a particular chart, and this I could have volume here, for example. And this could give me an idea of variations in volume of messages. You can have 1,000 messages, 1K each, or you can have one message, 1 gig. So it changes a lot the way the system works, and just by comparing these, we could essentially understand a lot of this information. So this is building a chart. We can have as many metrics as we want in one particular chart. They can come from any part of the system. So I just brought something from from BizTalk server, but I could as easily bring something from Windows and say that I want to compare these with CPU utilization and memory, for example, and bring it all together in one chart so that we have an idea of how the system is behaving. This is a chart, and charts will be what you will use the most, but it's not limited to that. We can also, of course, add any of those components that you've seen before, such as what are the unhealthy components, what are the top messaging patterns, activities and changes, errors, visualizing in a table instead of a chart, if that's more useful for the data there, bringing some data from the nodes itself, if those nodes have relevant information, and of course doing top component statistics as I was describing. This is the first lab, so I think that's a good segue for it. So let's do the lab. And so people will need access to an environment. So once you've signed up, you can tell me your email, and I can add it here to this particular environment so that you can play with it and essentially be able to do the lab. So let me just, so you can get from doing Azure monitoring. So we have done before logic apps and service buses, like single agents that were looking into those particular services because they are natural extensions to an integration environment with BizTalk. But we've seen demand coming over and over again that people are developing PaaS solutions in Azure, and they want to have monitoring for that. And so we built it in a generic way. So all resources within Azure, they expose metrics, and of course there is metadata available about those services, and what we're doing is ingesting all of those metrics exposed by the Azure platform into AIMS so that you can benefit from our machine learning algorithms to detect what's normal and generate anomalies, and therefore also notify you whenever there is such problems or changes in your environments that require your attention. We're starting to support these services you can see here on the left hand side. These are the ones that are mostly used from what we captured from feedback. This will be a fast evolving into more services. If you are interested in having Azure monitoring and you want a service that's not included here, you can let us know and we will do it. So it's as simple as that. It's configuration based for us. We just have to make sure we do testing to guarantee that all the metrics are being correctly pushed. So not only we are capturing metrics exposed by these services, but we are also capturing billing information in Azure. And this is to ingest billing metrics and learn what's the normal spend for each of those resources within Azure. And we can also find out when there is a significant deviation in billing and alert you of that. And this is to avoid bill shock. So you don't want to get to the end of the month knowing you're spending twice as much as before. You want to be in control of your billing as well. And of course, we're also ingesting events exposed by the Azure platform, and those can include health monitor information, can include activity logs, and any other logs that are available there, and we are ingesting them. Resources are grouped by resource groups, and so which is a natural grouping mechanism within Azure, and the goal is that you can essentially configure access to a subscription within AIMS, and we will essentially find out which resources are there and start ingesting metrics for all of those. You can and then of course benefit from normal behavior detection and anomaly detection. We are at this point we're not doing transaction tracing within the Azure agent. We are doing its performance monitoring that we are focusing on. Of course, you can still use any of the capacities of the platform, such as doing static thresholds, analytics, reports, dashboards, have events in and alerts. So one of the one of the things that you can get from these, of course, is the controlling costs by having the billing data, controlling the performance of each of the services in detail because of all those metrics exposed. Also, understand hybrid scenarios that you might have running both on BizTalk and on Azure, and have those connected together in the same AIMS environment and have visibility of those, and essentially also finding the correlation, such as something affecting your let's say Azure solution that has a downstream effect on your BizTalk solution, for example. And so those are the main points of us having Azure monitoring. So I want to pick your brains, and so who is using Azure at this point for production loads that are doing integration? So you can show hands. All right. And who is doing it as an exploration, so thinking of doing it in the future? Okay, everyone, almost everyone. All right, great. So that's what we think is happening. So a lot of people are, I'd say the vast majority are thinking of moving to the cloud, but might not be there quite yet, but will be there soon. And so we want to have these capabilities available as soon as possible, and they are available today. And so I want to do just a quick demo. Is just to show what's going to be showing inside our portal. So I just loaded a different environment where I have one resource group mapped here, and so what we see. So let me just show. So we have an Azure agent entry here, which is done by configuration, and maybe I'll start there. Sorry. We can add an agent to an environment to connect to a particular Azure subscription by providing some connectivity information, and this is done by Azure AD applications. So essentially, we need a client and secret alongside with the subscription information and domain information, and this will be our login towards the resources you have in Azure. And then we just need reading permissions to read the metrics that are relevant for our platform, and so we'll push them from there. So we just need this information as a starting point, and then once we have that, you will see in the topology the Azure agent registration, and each of the entries here is a resource group. And then when you expand a resource group, you see all the resource types that we're capturing and supporting at this time. And then we can expand and see the resource instances, which are essentially metadata nodes, and they benefit from what the platform does. And we can see here all the metrics that we are capturing. These are all the metrics exposed by the Azure platform. And this includes as well the billing related metrics, as you can see here, such as daily costs and hourly costs for each of the resources. We also support, for example, function apps, app service plans with including detailed billing information, data going in and out, CPU utilization, etc. And that applies across essentially all the services, including storage, for example, SQL Server databases, so all of those. But the same principles apply across all of them, so I'm not going to go through each individual one, but you can see we're capturing all of these metrics, and there are quite a few, so there is quite granular information available today. And in some cases we are, such as Cosmos DB, for example, we are I don't have a Cosmos DB instance. We are capturing at the Cosmos DB instance level, but we are bringing as well database level granular information too. So this is going to be quite powerful for monitoring Azure solutions. And what we want to bring in the next release of this Azure support is also mapping your solution, because if you are using logic apps and consuming messages from a service bus, there is a relationship there that we can of course show in a diagram, so it's easy to understand how this distributed application with all these microservices layout is, and which will help better understand the solution and troubleshoot it. All right, so that's what I have as an update for Azure of what you're doing today. And so let's go for the next lab. So lab number 2. Let's go for it, and feel free to ask questions, and I can clarify and help with a lab. And that can be used for any system. So I'm going to skip this introduction, which we have already gone through, and let's go through the SDK. So this is a .NET SDK, and the idea is to be able to create custom agents to collect metadata metrics and events, and that you can used to instrument any .NET application and create as a custom agent. To do that, you have to define agent metadata. So essentially, what is the data that we expect from that agent into AIMS? You also need to create a system. So essentially, it's a placeholder for all the metrics that are coming in, and then some code, some quite simple code to push the data to the platform. And you can get the SDK in our GitHub in that URL there. So these are a bit more granular steps into building a custom agent. So the first one is to define the agent metadata. Second one could be to add the SDK to a solution, authenticate with the API, so essentially getting a token to be able to communicate with our backend API, creating a system via code, getting authentication token for that particular system, and then code to gather nodes, links, statistics, and events, and then send them to the API. So this quick description of all the steps that need to be done. So you can define your agent metadata through the UI or through the API using a JSON config file, and essentially it describes the nodes that you will be collecting through the agent, the metrics that are going to be captured, events, status, and then for each statistic we also have to define an aggregation type, unit type, and name for each of those. So not a lot of information. You can actually see here the UI where you see the events, node properties, node status, node types, stat type groups, and stat types, and a quick snippet of what that JSON looks like. And as you can see, it's quite simple and straightforward. There is more documentation, of course, on this and how this can be done to get more details. Then one of the first things that an agent must do is to register a system. So if you think of a server, if you're doing server monitoring, you're registering the server name as the placeholder for all the metrics. And so it contains some of that information. This is a task often done at the installation time. Depending on the agent, it can be at different times. This is normally when we get a token stored in the config file for communication with the backend, and you do this by authenticating with the AIMS user. And so this is the C# code for that section. It's just pushing an object into our API, and in this case it just contains a name, an agent ID, a version, and an environment ID. The environment ID is the ID of the environment you create in AIMS. So it's just to know where to put what. Then we also have to inform about nodes, and if you look into the topology section of AIMS, each of those are nodes, and so this is where you create the nodes and then push information about them. And so you can see here some of the information about these nodes that is required to be sent, and here we see node references, which identify the top level node where data will be pushed into, and then in each of the granular nodes, as we can see here, we have a number of properties, a status, when it was created, deleted, or modified, and all this detailed information about that particular node. And this is how we keep track of changes as well, by looking into this information and how it changes over time. That's how we do the activities and changes, by looking into this information. As you can see again, so very brief amount of code. It's just code to capture the nodes that represent the system for which you want information inside AIMS. Then whenever we have those relationships across artifacts, such as whenever you are in an application and you go into a receive port or send port, etc., those are links, and links are just as simple as that. It's a from and a to node reference. So essentially you identify the node and you can refer to it and say, from this node to this node I want a hierarchy node, and essentially it will be represented in the UI, and you can navigate between them. And then you can also push events. So whenever an event happens in your application that you want to push it into AIMS, you just need to create an event object with a bunch of properties there, such as what's the event type, what's the message, what's the level, start time, some additional data, and which nodes it refers to. And by doing that, you will be attaching these events to the nodes that are relevant across topology, and so navigation across those will happen by this information. But again, super simple structure to create a reference to an event and just send to the API. All right, so this is the demo I'm going to skip. Essentially, was just, I already went through most of the code section here, which goes through each of the steps. The demo was just showing a solution where all these steps are there and pushing data. I don't think it's too relevant. I think it's more important for you to know how it's done and how simple it is to instrument. It's quite quick to do, especially if you're doing a .NET application. It's super quick. If you're doing an agent in .NET to some other application, you need to have some way to capture the information from that application, but then you just convert it into nodes, events, metrics, and push those through the system. All right, so if you want to see more about this, you can go and download the SDK. You can see our open source agents, and we have links there to some of them. Of course, we want you to experience these, and feel free to create your own agent. And we organize hackathons for the SDKs sometimes, so we can also do that. All right, and that's all I have from slides. So next thing is to do the last lap. And of course, questions and answers. You've been asking me questions throughout. Feel free to continue to do that. And that's it.
Dus ontwerpen dit net per definitie Apple